Welcome, I'm Bill Wake. We're here working on the 10th programming language. It's a subset of 4th, and lately we've been coming close to having a Repl, a read, eval, print loop, and I think we can get that in place today and then move on to kind of area by area improving the whole system. All right, let's do our usual start, or at least what I try to do. Oh, I'm starting to type clear on that. Just make sure everything's good. All right. So we have our eval done, and then yesterday we finished dealing with an input that can read a line of text and run it, or break it up into words, I guess you'd say. And I think we can put that together. So, well, I think the thing with a Repl is, right, in some ways it's kind of an infinite loop. And, I mean, you can get out of it with Control-C, which I think will start there. But otherwise, we would just want to, well, I think it's print a prompt, read some text, execute the text, go back around. Okay, so in our case, we don't need a separate P for print. That's going to be a command word that gets executed. All right, so what we need to do this, we don't have a system dictionary yet. We don't, yeah, that may be all that we really kind of have to build. I think let's just put this loop together and see what happens. All right, so I think Repl's the big deal here. All right, so it's going to have to do something. I think the thing is, I'm not going to try and TDD it because it's an infinite loop, and I think it's going to have limited stuff in it. All right, I may be wrong. All right, Repl, and then we'll return. I think we can also put our start in. Should this be the start? Well, let's leave that for a moment. All right, so somehow read eval plus print and loop. Okay, so a read, well, I want to do something first. I want to do a little prompt. Now, I think let's make a prompt. So a data segment and then back to our text, align to, just to make sure everything's good. Let's create a prompt, and I don't think we're going to reveal it anywhere, so that's fine. I'm thinking like 10 greater. That's going to be an ASCII Z. That. All right, so somewhere up here is the, let's put the loop statement right here. We'll load address. X0 is our prompt. And I think we'll just print, should do it, right? Read. Well, I guess let's go find our unit test demo that's got the read in it. We just called Unix read. Okay. And our input buffer, 100 bytes is a bit. Let's add that buffer. Theoretically, local variables shouldn't matter. Fill. I'm just going to go larger, 8 bits, fill it with zeros. Okay, we know we have to do this prologue, epilogue stuff. Oh, I learned something. Shift, Option, Command, V doesn't lose my... And unfortunately, you can't just remap Command V that's normally paste. Dialogues and stuff like that won't let you use this to paste in like Xcode. Okay, and a prologue. Well, I don't know that we need X10, but we'll just keep that for now. Okay, so this we'll print our prompt. We'll do Unix read. This one. Oh, we can use EQ, so let's do that. I guess up here equals, let's say input buffer sort of macro-ish. Size is 0. Don't think that's how he did it. Oh, comma. $250. And maybe to make this more, I don't know if this makes it more clear or not, but well, I don't even know if it has to be a quad. How about a byte? Okay. Slight buffer there. Okay. So if we read that, then we need to eval. Well, we need to tokenize. All right. So tokenize wants x0 to point to something, a string, and it replaces everything. I'm not going to worry about the new line for the moment. And I guess if I had to call that anything, it's kind of the read stage of things. Oops. Move x0 gets L input buffer. That should be load address maybe. Load address. Okay, and now we can branch to tokenize. X0 points to the word separated by 0 bytes. X10 points to the current word. Okay. I can't help feeling we can do better around this whole thing too, but for now, x0 points to the input buffer. And the loop part is branch to L Repl loop. It only lets you, well, let's see. It definitely restricts you to only read as many characters as they say you can. Does it? Well, it provides at most that many characters. And yeah, you can read more later. Whether that, well, that may or may not be what we desire. I don't know. But it definitely runs the limit there. I think that's probably a place for further improvement. Like if we don't get a new line at the end of things, we know something was weird, right? Because we apparently didn't reach the end of our line. Are we willing to I mean, how big an input are we willing to have? Are we willing to have a 2 gigabyte file typed in on the screen and store it and do things? I don't know. But yeah, in principle, you can read more later. I don't know if there's a flush to kind of flush that buffer and throw away those, but we'll look at that at some point. Okay, so I mean, this is me typing things in and how I think things should go, but we're going to make a prompt. We're going to do some stuff. We haven't printed anything really. We read, tokenize. Maybe a little space there wouldn't hurt. Then evaluate, and then go back for more. Okay. Now to make that the start of things, I think we'll have to, well, there's more setup to do probably, but we'll hit that at some point. Okay, so I think we want to say, is it start? Just dot start. Global. Oh, okay. Now, do we need these public? I don't know. But start, I'll put this down at the bottom. Start. Let's just BL here. Okay. And I suppose if you come back from that, we'll return. But I don't think that's going to be quite the way it goes. All right. Now we got to get the makefile going. Let's say, okay, we got Repl O, depends on Repl S. Let's say if you want to make a Repl, if you want to run Repl, we're going to depend on Repl.o and other stuff. But the bottom of it is we're going to run Repl. Test that out. Just Repl.out. All right, so he really needs to depend on all the stuff that comes with this. So core.o, like it doesn't need unit test demo. Like interpreter. Whoops. Dictionary. None of the tests. Okay, so don't need AS unit. core C-like interpreter dictionary REPL. Okay. And let's do a make. All right. Oh, we don't have our imports includes. We'll take a subset of that. Similar macros, Unix function macros, don't need these. Okay. Unix reload address. Okay, yeah, just those macros. Okay. Who's got load? Repltest.out, repltest.o. Okay. Repl dictionary. Oh, okay. We'll make a main. Because Repl test has its own main because it's going to run the test separately. And then Repl.o has its main because it's the real main. But I'll just make a main here. Is that all we need? We don't need these macros then. That's true. I'm going to alphabetize these. I think. Okay. And let's make Repl. I feel like I've left something out. Right. I guess Repl.o just has Repl.out. I think. Hard to get these things right. Hey, that's that's kind of something. Dupe one sub, return. Boom. Okay. Well, I don't know where that fault is. Let's ldb repl.out. Run. String length. Bad access, so I probably haven't aligned things enough. No. Well, what's the difference here? It was dying at string length. String length plus 36. I guess. Let's look at Repl.out. I mean, 36 seems like an odd number. And that's 8, 16, 24, 32. LDRB W3X1. Well, that's more like string EQ. Address 0. Oh, yeah, good question. Thank you. All right. Well, that's an interesting sign already then. We haven't dealt with error handling on this thing. We're going to have to. One pushes one on the stack. All right, let's do that. One dupe, one sub. Nope. I don't know if we're really Well, okay, we didn't put a dictionary in, all that stuff. So I think it's an initialization question. Oh, and we didn't initialize all the registers and stuff like that. So something's not good. Ugh. Yeah, I mean, I think there's something. Well, getting the prompt was good. We apparently read the stuff, and I think we tokenized it if we got this far. But evaluation went sideways. So, setup. Well, our dictionary test went out of the way to set things up, right? Somebody's got to call this. Excuse me. And it's not clear that pushing a 1 does the right thing either. I kind of don't think it does. All right. But we can do some of this work at least. Now, I don't know if that goes in main. I guess I could say that for now. Initialize dictionary. And initialize registers. And we need a prologue. Which I guess we're going to have to deal with just about everything. Okay, so let's see. We had our global list. This note, X19, X20, X21. But we also, we know where input buffer is. I guess that's something. So we're not putting secondaries yet, so that's fine. Input tokenized, all right. Well, X19 needs to point somewhere, right? So X19 is stack pointer. We got to have a real stack. I don't think I'm dividing things very well between files, but it's not dictionary. It's core. Let's give this job to core. Okay, so push X20. Well, a lot of the push and pop hoppy sort of things are all in here, so it's probably reasonable. New line. Well, appears not unreasonable. I don't know what that is. Oh, I think that was us speculating about things. So, for quad link offset. Yeah, I believe that was just pure speculation. Okay. Well, let's make this the text segment. Data. Data stack. Let's make that public. Now, we'll just make it moderate sized for now. Create the memory base by the registers. Yeah, I think. Well, I have a one of my post-its lying around says something about mmap and map anonymous. So underneath malloc and free, they use mmap, and we may need to. Well, like we're gonna have to have some. We haven't dealt with strings yet, but we got to have somewhere to put those. So, an area for strings, an area for secondaries. There's probably others, and maybe mapping it would be a good thing. But yeah, I'm gonna hard code it for now. All right, and okay, and so that's the data stack. And then here, dictionary, we called init dictinit. Okay, let's call data stack init core. All right, and then X19, I think we're treating it as globals, but I'm not quite sure that calling reserved for caller. Yeah, well, I'm kind of trashing it, but that's okay. So if the caller provides them to any routine below, they got to save it. They can't just use that register. So we'll never get that high as far as I know. So it's okay. So with that, really load address X19 is data stack. Okay, I don't think there's anything else to do. Let's look at a test. A test that uses the dictionary. I don't know if we don't really. Oh, well, we do that. Okay, yeah, we use a test stack. All right, I guess I can see that. Main. It's going to have to initialize the stack. Now, how do we get words running? That's a different thing, and we haven't really addressed it. I mean, we kind of did with, let's see, our eval. Okay, so eval does the loop. I'm not sure that's the right place to loop. There's sort of an outer loop and an inner loop. The outer loop says, give me a new line. The inner loop says, give me, handle the next one. Okay, so eval is constantly, it's coming in, pointing to a string. It's going to look up that word and do something. And right now we're just saying, look up that word and run it. There really has to be a bit more to it. You run it. Well, you need to look up. I guess the thing is, like, numbers have their own thing, and we're not dealing with that part. Really, when this process needs to be a little fancier. Yeah, maybe there's I'm thinking like eval 1 or something, but maybe not even that. I don't know. It's sort of a question of who's pulling the information, right? The way this is now, the outer loop, the one, the Repl one, pulls line by line, pull line, and then shoves a line at leval while not empty, and then it pulls item off that. In a way, I guess I was kind of not going there yet, but in a way, I'd like to just have something that says, give me the next word, and then it worries about, like, oh, do I have to go read a new line, or do I have to just get another word off this line, or how's that going to work, And I think that's actually a better design. I don't think this is impossible to make work, but I think it's sort of giving two pieces something that could be the responsibility of one. Now, eval versus like eval 1, this stuff is deciding, are there more words? This stuff's doing the actual work. This is finding the next word. So this little block is kind of an eval 1 sort of thing. Okay. But I think even if, well, is that right? We definitely haven't dealt with the case where a dictionary search comes up empty. Let me make sure that gets on our to-do. Handle failed dictionary lookup in eval. Okay. Oh. So if you Oh, these are all primitives, right? So we're just calling the primitive. All right. I don't think this is that bad then. Okay. In well, is it going to matter anyway? I was going to say for secondaries it's going to change it, but I don't think it does because we made the primers and secondaries very kind of symmetric or at least uniform in their header so that they could deal with this. All right. So it makes me less sure I know what's going wrong, but that's I can live with that ambiguity for a minute. I think we don't handle one because it's not in our dictionary. I don't even know if we put dupe in there. I can't remember. Add sub. Okay, well, let's do this a little systematically. Maybe that's okay. Let's alphabetical. Let's add dupe. And I think let's add one. So this is why those fourths like to have their own one, right? I'll call it push one. And we'll put it in core. Close some of these things. Yeah, we don't. What we did was we have the primitives in place to do it the proper way, which is to create a push followed by the number. But this is a thing in the secondaries. But it is common enough to have a word that's one, and I think some have a zero as well, because basically whatever base you choose, you're still going to have a zero and a one, and it's a little common. So that's kind of the justification, if you will. All right, so I'm making up, where's main? I'm making up a one function, so I got to put that in core. And I'm just going to put it there for the moment. Let's make push one. X0 is the contents of X20. So that's digging out the word we want. Let's just move X0 gets 1 and do a data push of X0 and return. Okay. And I realize I'm kind of semi-spiky kind of here. I don't have a test for this thing, but we'll get there. All right, I want to kind of push through the Repl first. All right, so main has dupe one sub. At least it has those. Okay, so now I think it might be more able to run. Oh yeah, because I think that was the failure we're having then. Let's go back to the run. It's got a 0 for the address, and the 0 is exactly what the dictionary returns when it can't find a word. So I kind of think that may be why there's fault there. All right, have I saved? Ugh, I'm going to make that mistake over and over and over. Core. Duplicate symbols, data stack, and interpreter.o and core.o. Okay, let's go find interpreter that I just closed. Data stack field 20. Well, I like the comment. We'll take this and move it. Core. this is important enough to justify that. Runtime data stack pointed to by virtual stack pointer points to the next place to write. Okay, good for us to say that. Okay. And make Repl. Oh, we need dictionary dot macros. Well, I need more than that, don't I? Load address. Am I missing one? Assembler. No, it creates a label push one for one, and had I made it global, but the value in the main, so I reference that label. Okay. One dupe, one sub. Did I make them all lower or all upper? All lower. Okay, I was wrong too. Okay. All right, LLDB Repl.out. Let's just see where it breaks. Start easy. One, bad access. Excuse me. That almost sounds like the dictionaries. Oh wait, this is before the dictionary. All right, so does dictionary init he does load address x21. But segfault 11. Oh, this is bad access. And it's saying, I think it's saying x0 is 0. Oh, we're 3BF8. Three B. 3D F8. Where's that? 3D F8. Jump if false. That seems odd. 3B F8. I can't read. Three B D F8. Okay, this is an eval. Right, so we got a 0 back from our dictionary. Well, we can look at tokenize. I wish we had all the labels for these things. Well, that's the dictionary probably. Or at least the stuff going in the dictionary. I'm sure I could get OBJ dump to tell me the labels somehow. Yeah, definitely. So, all right, well, 3BF8. All right, we just called dictionary search, and now X0 is 0. So that's the case we should be watching for, but I'm not clear why that's the case. I also wonder if we're not sort of stepping on start 2D's toes a little bit. Should it be the one that does this call? I mean, X0 being 0 is not going to be good for anybody. God, let's see. Where do we want to read memory from? We're after the address. I'd like to look at the input. So that's in Repl. Input buffer. And we can find this. Whoops. Okay, let's do this. Let's find our little prompt. Nope. 10 greater. Okay. Let's start reading there. I mean, we would expect data. Yeah, we definitely should do something. I mean, memory read failed for 5F5. What's that got to do? Yeah, those are L's, so they're not going to be visible. That's the syntax for that thing, right? What is... I mean, that seems like the right place to look. I mean, 10 greater space, that's this. 20 is space, so I'm pretty sure that's okay. Well, 3, 1. Oh, yeah, 1, 0, creator space. Okay. And that's what the fill should be right after that. 200 should be no problem. What is up with that? Okay. Oh, you're right. Thank you. Okay. 20 is space, then a 0 byte, an A, and a return. Oh, maybe we're getting our return. Oh. Okay, if I get back. All right, so our tokening is not doing well. I guess I could. Okay, here's my cheap hack. Just to get us through the moment. Right, I think that's what's going on. It matches that, and then otherwise it's looking for one new line, which doesn't show up in our dictionary. Okay. I mean, yeah, you can't do anything with it, but it's there. Okay. I need to take a break a little early today, so let's take our break now. We'll come back and I don't know, we'll either add a dot that does printing or we'll do something so we can tell if it's doing anything. Maybe we'll just go figure out that new line thing, but either way, we'll take 3 or 4 minutes and then be back soon. Welcome back. Okay. I think the /n's the kind of annoying part of that, yeah, we knew it was there, but we didn't do anything about it. Yeah, it should work fine. There's this notion of immediate execution. So if I put them if I do one, I should be able to do dupe. Well, because I don't have dupe /n. Okay, but in principle, yes, I should be able to put the words one at a time, or put them all in one line or whatever. It's not an issue. The only thing the thing we don't do in that is we don't have secondaries yet, and we don't have a way to compile. So once we have those, we'll have to kind of adjust that view a little bit. But at this point, it should just take each word, execute it, go to the next one, execute it, and so on. Okay, but let's get this new line out of here. We know what to do. It's just annoying. That's in Repl. And I think the easiest thing is we just zap that input character. So when you do this, well, the value that comes back in X0 is the count of letters. All right, so I think let's modify our Repl tests. I'll be a little more honest with things, I guess. Tokenize replaces spaces. Did we have an empty one? Oh, well, this is tokenize. Does nothing with empty string. This is the one, let's say deletes new line. Yeah, I want to do that. Deletes new line with empty string. All right. And then I want to say tokenize No. Well, who's... We could do it directly in tokenize. Maybe that's... I kind of wanted to do it here, but tokenize makes more sense in the long run, right? It's going to be the thing that knows this stuff. So where's tokenize? Up here. Okay. Points to a string with unused spaces. I guess I'm going to add something. It deletes the final new line and adds an extra 0. Okay, so we can do that. X0 points to a string with spaces in it. Should I pass in the length of the string? I think I will. Has length of string. Okay. Now, the tests need to reflect that. Okay. Tokenize. Well, honestly, yeah, that might be another way. Yeah, I like that thought. Because, well, in the medium term, maybe I should say, right? I think what token does is it breaks things into words. Well, the least sophisticated thing you can do is delete the spaces, turn those into new line or empties and empty bytes and go. The next level up to me is like, we haven't dealt with numbers as numbers yet. I think the tokenizer should maybe do something there, although maybe it doesn't have to. Maybe token is not the right place, but I think maybe the way I've seen in at least this other interpreter I was looking at, it basically, when it did the dictionary thing, dictionary lookup, if it gets it back and it fails to find it, then it says, oh, maybe you're a number. And he goes through and verifies that all quote, all characters are digits. And if that's true, it does the numeric action. And if it sees a double quote mark, or in some cases, some system, it's a bracket, it detects that and says, oh, you're a string, and deals with that. So it becomes more of an interpretation thing. So tokenized is pretty simple, but all right. So this said does nothing. All right, let's make another test. Well, let's do this. Tokenize replaces new line with 0. And he's ASCII Z. Okay, so that should be a string coming in. Load empty input. We tokenize it. Do we have an expect A already? Let's make it XY. All right, so we tokenize address X empty input. Now I want this to be L expect X. All right, X0. All right, this is L input. This should be empty input. Huh. I'm back to my string equal stuff. Okay. You know, sometimes you're leaning a little too far over your feet for your next step. I think I'm kind of there. Let's take L expect X. And then we'll call we'll call string EQ, and then we expect them to be yes and assert equal. Okay. X0 L and well, okay, now I'm going to add to it. Add X0 gets, well, if this is 0, 1, 2. X1, this is expect Y. String Q, expect 1 equal. Okay. And then we want to get the last, this, that is that, but there still should be a 0 at the end. I guess that's +2 again. X0 plus 4. X0 plus 4. X1, well, I guess I can do this. Load the byte, make sure it's 0. Okay. Yeah, that I think is more defensible. Take this out. Okay, so Repl tests should, if we add it. Now, I think we may break one of the other tests, but I'm going to leave it there for now. So, all right, this is good. X0 equals 0, X1 equals 1, X0 equals 0. Okay, so the string AQs didn't work because we didn't do anything with new lines. All right, so Repl tokenize replaces all spaces or new lines. Replace with 0. Okay, drop this. It's an extra 0. Okay. So if it's space, then we'll say move to next. Is that right? Okay, if it's a space, we're going to put a 0 in there. All right. I guess the same thing. Well, this is L. Replace new line. to 10. Branch not equal L tokenize move to next. Store byte 0 into x0. Okay. Plausible? Kind of. Okay, the first one's not right. Yeah, should work. All right, let's check the test. Eval tokenize. Expect X, expect Y. Okay. L and L input. So we think new line should have been a 0 at this point. Yeah, it might. Let's make sure I got everything right here. String EQ, I expect the string 0 to be there at an L input because we zapped this, I hope. String EQ, and I expect it to be equal. Okay, it's not. All right, I think maybe running this one might be the easy way. Okay, break, set. I guess here. Run. Okay, we'll do some stepping. We got to get past the prologue stuff. Here's the BL print. Oh, darn it. It puts a 0. Oh, good. No. Oh, yeah, you're right. You're right. You're right. There you go. Yeah. You're on it. Okay. Well, actually, I should do this. No, I should do. It's got to have a 0. I don't know how relevant that it is here. Well, let's make. Yeah, I think that's sort of okay. It's got 2 zeros. No, maybe this. X. I don't think that matters. Okay, let's go to this. Okay, so ACP, we've make tokenize replace new line with 0 character. All right, so now I can make Repl 1. Oh, I didn't take it out of the dictionary. Boom. All right, I guess that's good because it reflects that we have not put the right value in the dictionary. One dupe, 1 sub. There. We have a 0 in the stack. All right, I think for now, we should probably just automatically print the value on the top of the data stack. Yeah, there is another test. I misreading that, but yes, there's another test. So as far as I know, this has actually worked, and there's a 0 on the stack and nothing else. I think I would like to at least print the top of the stack and do it after every eval line. So at the end of the line, we'll print the content of the top of the stack. We could print the whole stack, but I don't want to write the loop, honestly. And mostly I care that the top is right. if we go step by step, we'll see it, and we can try a few at a time and then hopefully see it as well. All right, so that's in our REPL. And I think this is I'm regarding this as a temporary action. Okay, so I'm going to print L top of stack. Is that a normal abbreviation? Maybe just data top. Prompt prefix. And print. And then I'm going to do I have something that returns that to me? We had data at top, right? Where's that? Assembler macros. Data pop. Data top. Yeah, let's do that one. Okay. Data top x0. Print num. Was that how data top worked? Yeah, it just takes register. Okay, print num, and then I'm going to print one more. I'll put a post suffix in here. Okay, so in here we can put L data. Did I say top? Right. So one dupe sub all right. Yeah, so I duplicated the one, subtracted it, and now it's a 0. So yeah, that's it's a thing. All right. That's worth keeping. All right. Let's see where we are here. Okay, so set up real dictionary. We didn't quite do that. We did put in a right, a Repl loop. I think that's true. Yeah, 1 minus 1 equals 0. Okay, set up a real system dictionary. That's a thing. Report a syntax error. That's a thing. Test push 1 that I just kind of wrote in place. Read a string from a file. I'm going to move the file stuff down. I don't want to forget it, but that's there. And then also I want to make a question for now. Should we reorganize eval to not loop? And I think my answer is yes. But yeah, we'll come back to that one. I think some things here first. Okay. You know, I have to do this too. Make Repl. Okay, 1, 1, add 1, add. Yeah, okay. 1 plus 1 is 2. 2 plus 1 is 3. Okay, we can't leave that out. All right. A real system dictionary. I don't think it's going to take us long because we don't have a lot. And really, I don't know that I want to put it here per se. Whoops, here per se. Let's make a helper routine for this. So load system dictionary. And he's just going to be this. Right, and I think these 2 comments are a bit unneeded now. And this one is really kind of a TBD. We haven't got other registers that need loading yet. Oh, and have I lost this? No, good. All right, well, let's see what we got. Push, that's not public. In the compiler mode, when you type a literal, we're going to turn that into a push command followed by the literal, but the user never calls the push command. They do call this one, or could, dupe add sub mul neq. Dupe add sub mul. Well, I guess get neq in there too. Mul neq. And this is the sort of thing I don't normally tend to test because it's really, everything's in this table, and all I would do is try and replicate that table. And, you know, with it like this, I can see that, I mean, like, this is a little weird case. The name doesn't match, but given it's a number and can't have that name, that's fine. I can verify that these match manually. I think that's all I want to say at this point, or, you know, it's as far as I can test with it. If I ever had, you know, if I'd done copy and paste and had changed the mul and left it dupe and changed the neq and left it dupe, that would show up as an error. I mean, it would be a runtime error, but I don't think the test would be any better, you know. So these pure configuration things, I try to make them as simply readable as possible, and obvious verification. Yeah, exactly. We tested the dictionary creation. We tested the behavior of searching. This table is the table no matter what, so it's okay. And again, it's sort of a choice based on, I have made mistakes there, but I don't think the test would have saved me, because I think I probably would have copied the test and you know, used those words to drive the creation of it or something. You know, I don't think maybe that's a bad habit too, but it doesn't seem to be worth it as a test. You know, dictionary lookup of add is add. You know, we've already proved that dictionary lookup of some string that's in the dictionary is that value. All right, so that's the system dictionary. We can let's make Repl. Well, so much for that theory. What have I messed up? Repl out. Okay, load system dictionary. Load system dictionary. Data. Yeah, where is that? I got 3, 4, 7 entries. Should be in dictionary. He's got room for 300. Well, one and add were there before. I should have done that pure refactoring and check. Okay, I think we had add to, I think this is where we were before. Okay. It'd be else, so branch linked. I am calling other stuff, that's all. If you call other routines, you have to do the prologue and epilogue. Okay. All right, so I added multiply. So one add should put a 2. One add 1 add should put a 3. Multiply should do 2 times 3. Ha. Okay. It's amazing how much pleasure I get out of that working. As ugly of a little language as that is in some ways. I mean, we will add stuff to let you create methods that make it a little more readable, but I'll take it. All right, let's go here. Let's do our normal make sure I didn't break anything else. Be unlikely, but okay. Fill in system dictionary. Now, I don't think we have anything else that's usable. The ifs, that's more compile time stuff. So putting these in place is part of the compiling. Yeah, it's harder to test with only one. I mean, in principle, right? Somebody proved you can do a Turing machine with one instruction. So, as long as you have that, you've got something. All right, jump if false, jump. Those are generated as part of your ifs or whiles or whatever. That's a compiler step. Our tests, we manually generated them, but that's not the way a user doesn't have access to these words. All right, anything else that's going to be in there? Dictionary? No. Interpreter? That's the start 2D, end 2D. Yeah, okay. See, well, a print would be nice. And really, in fourth dot, a period by itself as a word says print the top of the stack. So we're kind of doing an implicit dot at the end of our, inside our loop. I'm okay to leave it that way for now. We will implement dot. We'll implement agaba things. Right. So let's see where we are here. Set the system dictionary. Yes. Report a syntax error. I think this is, let's extract that REPL 1 idea, because I think we'll be able to use that later anyway. But if the body, where's eval? Yeah, this bit, that's the real eval. This is something else. But okay, I'm gonna do it by extracting eval1, x0, x10. X10 points to the current word. Yeah, we need that for this. I guess we use it after too, so we can't. X10, they said X10. Okay, yeah, this is a little tricky to extract. All right, so let's make eval1. The core of it is this. He's going to need a return. He really needs to restore the same stuff. I guess maybe I can go back a tab. And he needs a prologue. Now the difference is we can't, we won't take x10 as a value. We only need, well, we need it coming in. I think we're going to take it in as x1. x0 gets x1. Well, no, that's almost the job of the person calling us, isn't it? We should have x0 pointing to a string, and then we jump to it. Yeah, I'm going to extract and then put put in the syntax error stuff. All right, so I guess if x0 point, this thing has the job to search the dictionary for x0, and if it finds it, call the routine pointed to. Eventually, I think this bit will become a branch to start2D or something like that, but for now, this is fine. And then I think we need x0 coming in, and then x10 is no longer our responsibility. So x0, where's eval? All right, this. I believe we're saying move x0. I believe what should happen is branch eval1, which does the search, loads the value, makes the call, returns the end of that one, immediately returns to this spot here. So I think that's okay. All right, he does call others, so he has to have a prologue. And let's make sure this still works. Okay. Yeah. I've got to go back. When I first started doing refactoring, the tools weren't really there, and you had to do things manually, and you'd copy and then adjust and then check and then do this and that. All right. That skill is important here, I guess. So we've extracted eval1. I think that works. That's a big step, and we'll take it as a thing. Eventually, I think eval1 will get renamed to eval, and eval will be pulled back into the REPL. But this is okay for now. Extract eval1. Yeah, good enough. We don't really go back to our history that much, so I'm not too... I try and say something real, but I'm not too worried about it. All right, now this... maybe this could be pulled over. I'll take it as an idea for future. Okay, maybe this is pull eval over to Repl. And then that stuff. Okay. So Repl 1. All right. Now the question is what to do if it goes bad, right? So if this comes back 0, I don't know what we're gonna do. I guess we're gonna ignore it. We'll print a message and move on to the next word. I think that's enough. Yeah, I think that'll do it. I don't need a super wonderful environment for this stuff, but I need to at least a flag that tells me something went wrong. I won't try to call that word, of course. So let's dictionary search returns x0. Okay, so let's compare. Let's write a test. I think the test is if you call eval1 with an empty dictionary, then, well, you get a message, but nothing got evaluated. That's kind of hard to check. Yeah, can we get that instruction? That's another way. Yeah, if x0 is 0, then we substitute something that knows how to run that dupe. That might be okay. I'm trying to think how to make it substitutable. Or, I mean, right now, eval1 doesn't return anything. It could. Like, I don't want to reinvent a whole try catch whatever thing if I don't need to. But I also don't want this routine to be involved in printing. And I am okay if he just calls a routine. This is tricky. So if his choices are he could return a value, and right now nobody looks at any return value, so all we'd be doing is providing a status code of some sort. And if you call us with a string, the caller knows the string, and if they got the value, it's like, oh, that's a syntax error. That seems like we could push that out to that level. Eval itself, right, doesn't return anything. And then that would, yeah, we can put that routine in. I mean, I can call it directly. So yeah, so that's another approach, but they're kind of the two common ones, right? You return a status value, and then the caller has to look at it and say, oh, there was a syntax error. I should call my print syntax error routine. Or you somehow pass in, well, it's either hard coded or you pass in a method that takes the input string and can format a message with it. If you hard code that message thing, then you've made it very hard to test. If you don't hard code it, you have to have some mechanism to go find it or change it or do things with it. So I think yeah, a default routine. Yeah, okay, yeah, that's definitely an idea. We commit to putting this word in. Yeah, I don't know if we want to. I think we just want to say we're going to put this word in our dictionary and use it. Now, I'm okay to say, like, hey, users, you don't get to make underscore your first letter of a word, and then we can reserve those for ourselves. I don't think that's an unusual position. So in that case, I mean, that's sort of a variant of the alternative, but I'm thinking let's put a dictionary header in that's like one syntax error, underscore syntax error. And it gets called like one of these. And in this case, it's just going to have a side effect. I think that works. Okay, so we'll sort of force a default case in. That's, yeah, I think that's all right. So the change would be in eval. So I'm kind of saying if I don't have a dictionary search, I'm going to do a load. If it fails, I'm going to load this routine. It's a little bit. Or I could search the dictionary for it too. That might be more interesting. Then I could substitute that word in my dictionary in a test very easily. Yeah. All right. Let's try that. So if okay, I'm just going to make notes for myself here. Okay, alternative 1 is basically return code, caller deals. Alternative 2, well, I think what we're saying is, I think my best version now is look up a fixed syntax error word and call that. And then in production, that word can be something that prints the word, the term that was not found. Okay. But then I had to save that string. Oh, that's so annoying. Or I could just hard code the system dictionary and say, I'm going to slap the routine I want in that first slot. That's another alternative. That's not bad either. I could patch that. So it lets me it forces me to do something with that. Return word in the first non-zero slot, first real slot. Okay, I think that's closest to your initial zero dictionary could be initialized with syntax error routine. I wouldn't do it instead of zero because I want to make sure there's sort of a boundary for it. But then we don't have to look the word up. Like, we don't have to look the word up for any of these. All right. So if I did that now, nobody would know. But we have a Repl test. So I guess I want to... How do you know where the word is that blew up, right? Because when you get X0 back, you're getting the address of what it found. So tricky. Oh, I guess I'll keep going on alternatives. Do that all day. X10. Yeah, we're maintaining X10 as that. It's not known outside this, but it's caller set. We're looking at it. Yeah, that's all right. Okay. That word assumes X10's initialized and points to a string. Okay. Yeah. My alt 4 is exception mechanism kind of thing. And I guess the other alternative I don't like is just hard code to print. Okay, but I'm not going to do that. All right, so I think I'm closest to this at this point. So we're going to assume the dictionary is set up with a word that that handles the problem, and an X10 points to it, and that's just the way it is. It's not quite a global, but it's an artifact of things, and we're going to make that be a condition of this. X10 points to the word. It maybe we should move that to X21 or something like that and make it a global. Yeah, error. Okay, so the test tokenize. I'm going to move these evals down. I think the way we've done it, tokenized tests kind of come first. That was a part of a test. Shoot. And I maybe I'm, whoops. That was okay. All right. So we want to test eval calls syntax error routine for unknown word. Okay. And then I'm going to, did I have my own dictionary in one of these? Yeah, this one does. Dictionary. Oh, dictionary init. Is system dictionary. Okay. I guess I can live with that. Well, let's just take this test for now, for starters. Okay, so this doesn't have to be our real one, but it embeds an assumption. All right. First entry is we're going to make another little routine. Capture error. Okay, so capture error. Well, we don't have a string copy. Although I'm feeling like I wish I had one. Again. All right. So put some data in. And the data is going to be L captured and it's going to be a byte question mark. Okay. Capture error is going to do something and return. And then what I want it to do is load address L captured, and then I'm just going to capture a byte. It's a little cheesy, but okay. So we'll capture that byte. We're going to do a store byte. Now we're going to do a loader x1 is x10 from x10, right? Brackets. Okay, load byte w1 that, and then we're going to do a store byte w1 to x0. Okay, so capture error, and okay, I guess that's all right. Capture error. Load the address of this byte. Load the byte pointed to by x10, store it in there. Okay. And then I don't think we need these because we just want to do an empty dictionary. Test stack, I don't think I need. Well, I needed something. Where's my word? The missing word is Fun. No, gotta do something I can remember what it is. ABC is 67. So let's just say C. Cot, cap, whatever. Doesn't matter. All right, I'm only going to capture the C. So this L input, I guess I'll load. Well, I don't think this matters. Load address L missing word. We're going to run eval1, and then we expect, we'll do this. X1 is 67, capital C. Oh, thank you. Assert equal. All right, I think that's kind of a test. All right, we set the dictionary. We put in a bad word, a capturing tool for this missing word. We load the missing word. We give it to eval1, say evaluate cap. It comes back and says, okay, I did. And L captured, if we get whatever the ASCII for question mark is. All right, I guess I'll be really good about my assertions. ASCII chart. All right, where's question mark? 63 decimal 63. Okay. So I expect we'll see a 63. Well, no, I expect it'll blow up. I expect it'll blow up. Yeah. Did I save? Okay. If I run the test. Sure enough. Well, of things I expected, this was not on the list. Our address, XCC. That seems like I've not got these as data. Data. This is text. Boy, that error leaves a bit to be desired. Address CC R extern equals 1. address L captured. All right, I'm going to take this out for a moment. I don't see how those could do it, but this line could theoretically. Let's see if we get the same error. We do. Okay. A clue of where we're looking at would be great. Okay, I did have a dot that I left behind. I think I had deleted it. Okay, so text align to start data text data text data text data text data text. I can get into this. Data align text align. Ugh. I think it's from really moving things around. All right, let's just take it doesn't it doesn't build because we reference things. Okay. Let's paste something at the bottom. So 200 to 280. Well, this is the new stuff, so let's cut it. Okay, so it's something in the new stuff. Data aligned to a missing word ASCII Z captures a byte. Maybe I have to do ASCII. That seems plausible. Eval 1. Okay. Repl needs to say global. Okay, there's the segmentation fault I'm looking for. because that's what we did before. We just crashed when we got a 0 in there. I think if we what's eval? No. Eval. Is that interpret? I'm expecting a crash at that same place with a 0. Yep. Okay. All right. So the problem is this routine is not being called. Where to go? This one. Okay. So that's nothing to do with this now. That's all to do with the Repl. Okay. Okay, so compare x0 to 0. I guess if it's not equal, we're gonna jump. Call routine. Call found routine. Okay. And then otherwise, boy. We load address. Really, it's x0 is system dictionary. Add x0 equals x0 plus. Well, the first word, we got those 3 zeros. So if you do 24, you're at the address of the starting address of the second one, but we don't want to point to the pointer back. We don't want to point to the name. We want to do plus 16. I think I can do the math here like that. All right, and now x0 points to that cell that contains the pointer to our capture routine, I hope. And let me just double check dictionary, system dictionary. I mean, it gives us a little more dependency on that. I think that'll do it. We did a little of this somewhere. Huh, maybe not. Guess we'll find out. Call found routine. Colon. Syntax error for unknown word. Okay, well, that's kind of dying where it would be interesting, I guess. If it finds a 0, it's going here. It loads this address. Add that address. XR should be contents of X0. That seems right. Okay. Yeah, that's true. I wonder if parentheses are legal here too. Well, they are. I don't think that's it. Okay, dictionary init we'll skip over. Branch eval 1. Okay, so we're stepping in. Calls dictionary init plus 12. Okay, that's our search. Okay, so we're ready to call that. I'm going to do a next. Okay. Did not find it. Okay, so if I step compare, branch not equal should leave us at C14. Okay. So we're going to load the system dictionary. So step. All right. Reg read X0. System dictionary. Mem read minus count 200. This. Okay, so there's 0, 0, 0. D048. Okay, so that's the address of this. Then this should be the string. And oh, it's a pointer to the string address. Okay. 40CD. We're not going to have that. Followed by the word address of the capture routine. Okay, so we got X0 loaded. Oh, wait. Okay, so X0 right now is the system dictionary. If I step, X0 should be plus 40, which should be this. Okay, so if I load our X0 with contents of Xn. Okay, I'm expecting this to be 3A-E0. Step reg read X0. 3A-E0 is capture error. BLR X0. So 3C24, this should jump into the capture 0 routine. All right, maybe that's the problem. Read X10. Now this should be cap. X10. Now let's go back to capture error. It's going to load the address of captured. Then he's going to get X10. Well, what gives us... Okay, X10 is this, 3B91. That seems off in the weeds somewhere. Now this has X10. What's he doing with X10 though? Okay, he calls that this thing Repl. Okay, Repl set X10. Eval uses it. And sets it before we get in here. Let's find, well, let's update this. This address is just way, way up there. It doesn't look at all like a real address. Oh, but what is this? 3B. No. I thought maybe that would be CAP. So 3 1, right? 4 1. 4 times 16 plus 1 is A. A. So we should see 4 3 4 1 4 something else, maybe 5 something. All right, that's not a string. 3B, 3 times, that's 49 is, that's pretty high, I think. Where's that ASCII chart? 3B, semicolon. Doesn't sound like anything. 9 1. 3B. 9's too high. F1's compare. Okay. The question is, who's messed up at this point? All right, I guess I'll step a little further. We're not going to solve it today, I guess. All right, that's the add. That's that. Okay. Reg read x0. Well, that should be where it's going to write it. 40cc. cc. So in here somewhere. Yeah, one too many indirections sounds like what it must be, but all right. Well, we'll pick up here tomorrow. I'm not going to solve it in 2 minutes. All right, but I'll leave a note for us. Check that X10 is right going into eval 1. Okay. Yeah, that could be. Do we have time to check that? X10. No. All right. We'll pick up there tomorrow. Thanks for joining, and tomorrow 2 to 4:30, 7 to 9:30 p.m. UTC, and have a good evening. Take care. Bye-bye.